2.5 hours later.
Okay, welcome guys. Yeah, today we're doing a video about making a forge. Yeah, I think there's a lot of other videos you can check out on YouTube. This is not the absolute perfect way to do it. Obviously do a lot of research before you attempt something like this. It's very dangerous. You're working with explosive gas, you're working with heat, you're working with flammable materials. So yeah, take care and enjoy the video. Okay, so forge, obviously if you clicked on this link, you basically already know what a forge is. Forge is just a tool that you use where you're going to heat your steel. If you're making knives or you're doing blacksmithing, you're going to heat your steel, and then you have got an anvil or some other object that you're going to heat your steel on with a hammer, and then basically shape your steel in whatever form you want. The main elements of a forge would be obviously something that's going to create heat. In our case, we're going to use gas. And then also you need a body and you need some form of insulation to keep the heat inside the forge as well. Basically, there's three types of refractories that you can use to isolate the forge with. You can have your ceramic blanket, which is what we've got here. I can open it up later and then I can show you exactly what that looks like. Basically, it's a blanket, almost like fiberglass, just made out of ceramic. And this is basically going to be your best type of insulation that you can use on a forge. The downside to this is that it's not very strong, it's not very durable. So your heating or your flux will eat away this material quite fast. Also, if you poke it with the object that you're trying to heat or anything that you put into the forge, you're basically going to slowly but surely destroy the material as well. The other thing is it's also a little bit toxic if you breathe it in. So you're going to have to wear a respiratory mask, some eye protection, something on your hands to keep it from getting on you. Then the other material that you can use is refractory cement. It will come in a bag like this or some other form. You can buy it from your local refractory supplier or knife making supplier, wherever. Glass blowers, sometimes they keep these materials as well. This is rated at 1500 degrees Celsius, around about 2800 degrees Fahrenheit. This is basically not, you can go higher in rating. I think it goes up to about 1800 degrees if I'm not mistaken. But yeah, so what I'm going to do in our forge, the one that I'm building, is I'm going to use this as an insulation material around the forge or on the inside of the forge, and then I'm going to line it with the refractory material or the castable refractory, and then yeah, basically after that we're going to put lids on, we're going to put it on a stand, and yeah, but we'll talk more about that later. Okay, what I'm going to use for my body of my forge is this steel drum I've got here. This is basically just scrap that I have laying around. Obviously it's not too long and we're not going to build a forge this size. You're going to need a lot of gas to do that. So what I'm going to do is I'm going to split it down the middle. It's roughly 39 centimeters in length. Not sure what that is in inches, but you can go work that out, use a calculator of some sort. What I'll do is already got the back on the back side there, so that's going to stay on there. I'll just cut my back hole on that. This will be my front, and then I'll line the. There we go. Oh my God. So what we'll do is we'll take the ceramic blanket, line it on the inside. What I've got is I've got one inch ceramic blanket, 25 millimeters. So we'll line that on the inside, do 2 layers of that, maybe 3. We'll see what kind of space I have left when I'm done with that. And then after that we'll line it with the refractory cement, and yeah, we'll leave that to cure for 2 or 3 days, and then in the meantime we'll get started on the burner. Okay, so we're done with the forge housing, more or less. We might need to do some alterations on the outside, maybe weld some hinges on there at a later stage once we're done casting and we've got a better idea of what we're actually going to do with the lid. But for now, what I would like to do is I'd like to do the ceramic blanket inside, and as you can see, I did put some tabs inside there, so they'll just hold the ceramic blanket in place while we're working, and then make it a little bit more secure while we're working with that. Yeah, the ceramic blanket, as I've explained earlier, is that it's quite dangerous. It does say on the box that it causes possible risk of irreversible effects, and it's got some harmful byproducts when it's heated above 900 degrees. So yeah, you do need to be careful when you're working with this blanket. Get decent eye protection, wear gloves, get a respirator that is going to be adequate for filtering out that particles that it's going to release. And yeah, think before you just do something. Never assume that you know everything. That counts for me as well. But I mean, yeah, you can do a bit of research on that as well if you want to. But do be careful. Yeah, so let's get on with it and get it done. Okay, so the type of mix that you want, I'm not sure why it needs to be so specific in terms of consistency, and why they talk so much about not over mixing the mix itself. But I think what is happening is if I look at all the makeup of the refractory, it's quite a few different type of materials inside it. So it's not like normal Portland cement would be something that's the whole bag has got the same type of thing in it. It's like only cement inside there. But this has got something like cement in there, and then it's got also it's got a little bit rougher material, and then other material which I think is maybe a little lighter than the rest of the mix. So I think what's happening is if you put too much water inside there and your mix is too wet, then you're going to have some of the light materials gathering together, and you're going to have the heavier materials sinking to the bottom as you work it, and then you're not going to have a uniform distribution of all the different particles inside the mix, and that's going to make your mix maybe a little bit weaker than it should be. I think that's the main reason why they want you to use the water sparingly when mixing when mixing this. So yeah, okay, so basically just putting it on there, and then you can, it looks like it's too dry, but I can see that as you work it, the water does kind of come to the surface and make it a little bit more workable. So I'm not sure if I'm doing this right, but we'll carry on like this and then finish it up and then see what it looks like.